Hi, good evening. Today we discuss about the electrochemistry, the transport number we study about today. First we know about the transport number. What is the transport number? During the electrolysis, the current carried by the anions and cations and the amount carried by the each is proportional to its speed. If V represent the speed of the migration of the cation and anion, then U divided by U plus V represent the fraction of the current carried by the cation, and V divided by U plus V represent the fraction of a current carried by the anion, and it is called a transport number or Hitrop's number. It is denoted by the symbols like a T plus and T minus. Hence, transport number of the cation is equal to T plus current carried by the cations divided by the total current. In the symbol U divided by U plus V. We already see the transport number of a cations, and similarly the transport number of anions also T minus equal to V divided by U plus V. The fraction of the total current carried by the ions is directly proportional to their velocities. It is a Hitrop's rule. T minus plus T plus equal to 1. Both cation and anions equal to, it means both cations and anions equal to 1. Determination of a transport number by the two ways. One is a Hitrop's method, another one is a moving boundary method. But now in this session we discussed about the moving boundary method. The concentration of the solution are so adjusted that hydrochloric acid floats over the cadmium chloride, since HCl is lighter than the cadmium chloride solution. A sharp boundary appears between the two solutions. The selection of the indicator electrolytes is done carefully so that its cation do not move faster than the cations whose transport number is to be determined, and it should have a same anions as the principle of the electrolyte. Cadmium chloride fulfills the both requirements. The second point is the mobility of the cadmium ion is less than that of the hydrogen ions, and it has a common anions with the hydrochloric acid. Here we see a circuit here. It is in a vertical. It is used for the circuit for the moving boundary method in this only. This method is based on the direct observation of the migration of the ions in an electric field. The conductive cell in this method consists of a vertical tube filled with a cadmium chloride and hydrochloric acid. This is a vertical tube. Here circuit is in a vertical tube. Cl is a principal electrolyte and CdCl2. Cadmium chloride serves as the indicator electrolyte to enable formation of a boundary. Then we see about the how it works. The anode is stick of a cadmium metal increased at the bottom, while the cathode at the top is the platinum foil. When some current is made up to flow through the conductivity cell, the anions move towards the anode, while cation means hydrogen ions followed by the cadmium ions move towards the cathode. The boundary separating the two solution also moves upward, and if the boundary moves through the distance 1 centimeter from A to A or B to B, then the volume of the liquid that has moved up is length A centimeter square. Let the concentration of the acid be C gram equivalent per liter. Then the number of a gram equivalent of H plus ions carried towards the cathode. Thank you.